Hey everyone, and welcome to this explainer. I'm Professor Argao Ambelu, coming to you from the Center for Water Research over at Addis Ababa University. Today, we're diving into something I've been working on personally, a really critical, first-hand investigation into the safety of Ethiopia's drinking water. We're going to be looking at a massive amount of evidence, literally combing through the scientific literature all the way from 1980 right up to August 2026, just to figure out what is actually going on with our water supply.
So, how safe is the water we drink? It seems like a really simple question, but every time you turn on a tap or draw water from a well or maybe collect it from a rural spring, you're actually interacting with this completely hidden microscopic world. And today, we're going to look straight at the high stakes of this hidden crisis. We're moving way past just, assumptions to see exactly what the hard science is telling us.
But first, let's ground this whole investigation in a pretty grim reality. Unsafe water, poor sanitation, and bad hygiene, these have devastating real-world consequences. Just in Ethiopia alone, national estimates tell us that waterborne diseases contribute to more than 70,000 deaths of children under the age of 5 every single year. 70,000! Diarrheal disease is still a leading cause of childhood mortality. So you see, this research, it's not just some dry academic exercise. It is quite literally a matter of survival. And it establishes exactly why getting our scientific data right absolutely matters.
Okay, let's dive into this. When I first set out to understand the real scope of this crisis, I started by looking at previous meta-analyses, studies that had already pooled data from across the country. But, well, I quickly realized we had a massive problem. I couldn't just trust these past assumptions, so I essentially went on a bit of a scientific detective hunt. Instead of just accepting published data as gospel, I took candidate primary studies and independently verified every single one against its original publication, literally going line by line.
And what I found when I went back to those source texts was, honestly, it was deeply alarming. I found some shocking errors that had just silently slipped into the scientific literature. For example, we found reversed percentages for total and fecal coliforms in a study out of Tigray. We found completely mislabeled E. coli results in a Sadama study. There was even one study where the sample size was recorded as 21, but the original publication actually tested 604 households. That understated the true sample size by more than an order of magnitude. And perhaps the craziest part, one of the cited bottled water studies simply didn't exist as described. At all. A completely different Ethiopian bottled water study was actually in its place. Honestly, this just proved to me the absolute necessity of independently verifying scientific data. We just cannot build life-saving public health policies on a foundation of errors.
So, by actively throwing out that flawed data, fixing the mislabeled figures, and then aggregating only the rigorously verified primary studies, we were finally able to see the true, unclouded big picture. This gave us our verified truth, a really robust data set of 42 primary studies representing up to 17,659 water samples. Zero assumptions, just raw, transparent, verifiable data. Now you might be wondering what the data actually said. Well, here is the first hard statistic we pulled from this pristine data set. Looking at the pooled prevalence, we're seeing a massive 58.6% contamination rate for total coliform across Ethiopia. To put that into perspective, that means nearly 3/5 of all the sampled water contain these broad environmental and fecal bacteria indicators. That is a whole lot of contamination. But we need to look a little closer. When we narrow things down specifically to fecal coliforms, which, by the way, are much more closely tied to human and animal waste, the numbers are still alarmingly high. Across 31 of those verified studies, a staggering 43.1% of all samples tested positive for fecal coliform. And then we get to this final core statistic, 26.9%. That is the pooled prevalence for Escherichia coli, or E. coli. Now, I really want to emphasize the clinical severity of this specific bug. E. coli is the most direct marker of fecal contamination we have, and it's intimately tied to severe diarrheal disease transmission. It's bad news. And more than a quarter of the water sampled across these studies contained this highly dangerous pathogen.
Okay, let's move to the timeline and see how this builds, because this is where we actually uncover a genuine glimmer of hope. In our meta-regression, we looked at how these numbers shifted by publication year, and while total and fecal coliforms didn't really show a massive uniform drop, E. coli prevalence absolutely did. So, from 2014 to 2018, it sort of hovered right around 32.4%. Between 2019 and 2022, we saw a slight drop to 31.5%. But look at the 2023 to 2026 period, a really significant, hopeful decline down to 19.0%. This continuous decline strongly suggests that our targeted sanitation and water safety interventions are actually working. They're successfully reducing the most direct, severe markers of fecal-oral risk, even if the broader environmental indicators are a bit more stubborn. And this brilliantly illustrates the major plot twist of our whole investigation. The absolute biggest driver of contamination? It's not about what geographic region you happen to live in or even strictly what year it is. It is entirely about infrastructure. Look at this stark, undeniable contrast here. We found 51.1% fecal coliform contamination in non-piped community sources, things like unprotected wells, springs, and rivers. But compare that to just 9.6% in piped municipal supplies. It's like night and day. To really emphasize the sheer scale of this infrastructure divide, our analysis concluded that non-piped community water sources showed roughly 2 to 5-fold higher contamination than piped municipal supply. I mean, this is literally a life-saving contrast. The physical and chemical barriers that you get with treated, piped water, like protected wellheads and chlorination, they interrupt the transmission of disease in a way that just grabbing water from the open environment never could.
But actually, scratch that. Even piped municipal water isn't perfectly immune. And our standard indicator tests, they sometimes miss the hidden threats. During the review, we found recent primary research right here in Addis Ababa that actually isolated specific, highly resistant pathogens like Vibrio cholerae 01 and E. coli 0157H7 directly from drinking water and wastewater. These are epidemic-prone bugs, and they have massive multi-drug resistance. The cholera strains, for example, showed 100% resistance to penicillins. So this really reveals that generic tests don't always catch these specific, highly resistant bugs circulating in our systems.
We also stumbled upon a massive, glaring gap in the Ethiopian water quality evidence base, and that is surface water. In all of our searching, the primary literature on rivers, lakes, and streams is just dangerously sparse. For example, there was this one rare study on the Kelter River, and it showed immense pathogen loads. We're talking bacterial counts vastly exceeding WHO limits, isolating Salmonella and Shigella species, the works. Yet these vital surface water bodies, which are used directly by some communities and indirectly for agriculture by so many more, they remain desperately under-researched compared to drinking water. We urgently need future exploration here.
So, the crucial point is how we actually translate all these findings into action. I've got 4 core, actionable recommendations for researchers and policymakers. Number 1, we absolutely must standardize our reporting and indicators in primary research, making sure to note exact sample years and source types. 2, policymakers have got to prioritize investments by source type, specifically expanding piped and treated water coverage, because as we saw, that's the biggest driver of safety. Number 3, researchers have to rigorously verify all data against original sources. We have to permanently abandon blind assumptions. And number 4, we need to expand our public health surveillance way beyond generic coliforms to look for those specific multi-drug resistant pathogens and definitely extend our monitoring to those neglected surface waters.
I want to leave you all with a final, somewhat provocative thought, something that has driven this entire investigation for me from day one. If our baseline scientific data is flawed, how can we successfully build the life-saving infrastructure of tomorrow? True progress in global health requires an unshakable foundation of scientific truth. We have got to get the numbers right if we ever hope to get the solutions right.
Thank you so much for joining me in this vital investigation into our water safety. This explainer was independently verified and narrated by me, Professor Argao Ambulu, from the Center for Water Research at Addis Ababa University. Keep demanding the truth from the data, and as always, stay curious.